World-class processing starts with our clients and the commitment they provide to their ultimate customers. Our teams thrive on solving challenges to unlock the full potential of resources through our services. Assessment of resource data and project needs to develop tailored solutions. Industry-leading engineering design founded on innovation. Project delivery that gears assets for prime performance. And operations that optimise production outcomes safely, profitably, and sustainably. Success starts with truly integrated minerals processing solutions from a team whose passion is to drive global best practice forward.
Hello everyone, and thank you for listening to this presentation. My name is Glenn Stieper, and I'm the Mineral Processing Manager here at Glencore Technologies in Brisbane. Today I wanted to discuss a growing challenge for the mining industry, and that is the degrading ores and how the future designs of concentrators is going to have to deal with this challenge. In the mine industry, we know that a lot of the known and undeveloped copper ore bodies are becoming more complex. As you can see across this graph here, this is looking at copper. It used to be around the 1900s, it was around 4% copper, and now we have a sharp degrading ore to around about 1% copper. So you can imagine the challenges that this is going to present to us going forward. It means that mines of the future are going to be lower grade, they're going to potentially be deeper, larger capacity, and what this will ultimately mean is a much bigger footprint. So with larger plants and then higher costs, it means there's more probability of overlooking things like the environmental and social costs. Further to this, if you see the graph down the bottom, you can see that the expenditure, and this is looking at for new discoveries, you can see that the expenditure is dropping off as well as the new discoveries. So just again, adding more to the challenging environment ahead of us. If you look at the market trends, what are the investors telling us? They want less environmental impact and lower emissions. So again, it's that carbon footprint. They also want more sustainable and safe methodologies. And with this, they want lower capital and lower operating cost. Now, of course, that also means no drop in performance either. So the problem, there's two really competing trends, and we need really the processors need to process more, but they also need to do it with less. So essentially, the challenge that we have in the market is that we need to process the same or more throughputs using less equipment and less energy. So here at Glencore Technology, we've taken on that challenge, and we think we have some solutions to some of these problems at least. And so that's what I want to talk about for the next part of this presentation. So we've recently been awarded a large lead zinc concentrator, which is in Russia, called the Ozorne project. It's an 875 ton per hour circuit comprising of 100% Jameson cells. This circuit replaces the planned 63 tank cells with only 19 Jameson cells, and it's less than half the footprint and also less than half the power. Also incorporated in this concentrator is 3 new M20,000 isomills. So this is our latest and biggest isomill in the market, and this will be a 5 megawatt motor. Commissioning of this circuit will be in Q4 2022. And not just the footprint in terms of the floor space, but also the height is another big reduction. Because we don't have any agitators in Jameson cells, it means that there's no need for lifting in terms of lifting the agitators out of the tanks. Here's a plan view of what that looks like in terms of that footprint saving. Another project we have is a new Britannia copper mine in Canada. This circuit, again, not as big as Ozorne, but again, follows those same sort of concepts where it's 11 conventional cells being reduced down to 4 Jameson cells. It's a half the footprint and also a significant reduction in power as well. commissioning of this plant is in Q4 later this year. So we're pretty excited about that one coming up very shortly. So the path ahead, since we've sort of been launching and pushing into this field of the full concentrators, and the market starting to become aware of the substantial savings across the board, we have had a lot of inquiries, and we're doing a lot of extra work in terms of detailed test work programs and also engineering as well. So this is just some of the examples of the ones that we're currently working on. And you can see across here, there's some of the images of the plants, basically some indicative views of what they look like. Again, we don't engineer these, we simply supply the equipment, and then we give people an understanding of how these can be laid out. But obviously the engineering houses are the ones that will finalize these designs. Up top here, you can see this is a small 2 million tonne per annum copper plant that we're currently working in conjunction with Sedgman's. So it's a nice, neat, very low to the ground configuration. So just a quick case study that we're working on. So with Sedgman's, we've been engaged, and this is a 100% Jameson cell cleaning circuit. So this image here shows that these are E10 cells, 3 of them, and it's nice and compact in terms of its footprint and how low it is to the ground. They looked at a comparison bottom-up estimate between our circuit and a equivalent mechanical cell circuit. And what was demonstrated was a reduction of 480 kilowatts of power, 44% reduction in operating costs, 24% reduction in capital, and a 500 square meter reduction in footprint. And accompanied with that, it was around about a $500,000 reduction in capital spare saving holdings as well. So going forward, we're also engaged with Sedgman's looking at designs around sort of all-in-one E-cells, where it's becoming sort of a more modular design, looking at the ability to make them at a lower cost and also to reduce some of the delivery schedules with that as well. So very actively engaged in a lot of other jobs as well, and a lot of other concepts. So what do we believe the benefits to the mining industry? It's obviously that low profile, the Jameson cell IsaMill being low to the ground, giving that low layout cost, and also the safety benefits of not working at height or working under loads. There's no blowers or agitators, accompanied with the high efficiency of the IsaMill, which gives that low power consumption. With up to 50% reduction in footprint, it means significant savings in capital, particularly in cold climates where you need to enclose the entire building and heat it as well. And substantially less equipment means significantly less spare parts and also maintenance requirements, which obviously relates to an OPEX cost reduction. And with over 30 years of proven IsaMill and Jameson cell performance, it means that you're dealing with a well-proven technology. And because of the simplicity of the circuit, it means that you're going to get consistently high performance. So what goes into the design, or what makes that circuit so special? It comes down to our technologies and some of the developments we've had recently. So if I look at the IsaMill in the original ones, a lot of you might see out in the market, they're up on these sort of high platforms, a lot of concrete, some of these up to 6 meters high. We've now got reduced footprint where we've basically taken the IsaCharger and moved it to the side. And that's enabled us to drop the entire platform right to the ground. In this case, it could be as low as 1 meter. We also have the removable removable platform. So when maintenance is not required, that platform can be removed, gives you a laydown area for other things to do. And also, obviously, not working at heights gives you that safety advantage. If I look at that, then this footprint here and how it sort of sits within the footprint of some other vertical stirred mills, you can see that it sits within the footprint on the ground, but also substantially lower in terms of height. So it has that double benefit. And just some new models, that have come onto the market. We've got the M15,000, which is recently commissioned at Red Dog, and the M20,000, which we will be commissioning in 2022 as part of the Azorne project. On the Jameson cell, what we have is the development of the new 8512 Jameson cell, which is both B and Z design type. What this does is essentially it doubles our capacity from our B 6500 24 downcomer cell. So this enables us now to move into much larger applications, and we can now treat up to 1,500 tonnes per hour per unit. We have Cadia later this year. We'll be commissioning this cell you can see here, which is the Z cell in a roughing duty. And then 7 of the B designs will be installed as part of the Azorne project. So just a quick overlay of how we design. So you can see on the side here, this is just some site test work, demo information in terms of where this operated, in terms of where conventional cells, so it's 5 times upgrade in a roughing capacity, and how that relates to a grade recovery curve. And then essentially what we would do is this material is highly liberated, and as you work your way down this curve, this becomes more and more into the composites. And obviously down the bottom here, it's highly composited, and this is where your lower grade, but you obviously require that to maintain your recovery. We would then design the circuit so that up here you'd be functioning as a very sort of a deep froth depth, high wash water and low air to pulp ratio. Down the far end, we'll be functioning as more of a shallow level, low to almost no froth washing, and also a very high air to pulp and maybe even crowders. So obviously a very aggressive pulling down the far end is how we would operate them, as opposed to more of a scalping where we're making a very high grade product. So what does we believe overall this offers to the mine industry? I think it's an environmentally friendly response to the need for sustained or improved metallurgical performance for increasing challenging ore bodies. It also presents significant reduction in CapEx and OpEx, improving the financial viability of treating these low grade and high throughput applications. It's also a very simplistic flow sheet in operation. So it means that in areas where maybe there's limited resources, it enables you then to install circuits in these places and still achieve high performance. It gives you the reduction in energy requirements, which benefits not just areas where power is restricted, but also where power prices are also very high. And we believe it's generally a progressive movement in an otherwise slow-moving industry. So thank you very much for your time. Thank you for listening. And if you would like to get in contact with us, please visit our website or email us at those emails below. Thank you very much.
World-class processing starts with our clients and the commitment they provide to their ultimate customers. Our teams thrive on solving challenges to unlock the full potential of resources through our services. Assessment of resource data and project needs to develop tailored solutions. Industry-leading engineering design founded on innovation. Project delivery that gears assets for prime performance. And operations that optimise production outcomes safely, profitably, and sustainably. Success starts with truly integrated minerals processing solutions from a team whose passion is to drive global best practice forward.